Hello, my name is Denton Williams. I am currently this is a video for Fundamentals of Physics with Corin Rombach as my instructor. I'm here to explain to you the inverse square law in relation to light. What that means is the inverse square law in reference to light can be used in videos, photography, and theatrical lighting. With that being said, it refers to the actual object itself. As you can see, I have two cars here. I'm going to demonstrate how this actually works. It shows how an object or a subject is illuminated based on the type of light that you use in that scene, or the type of photography that you're going to be taking at that time. Now, what I'm going to use is a flashlight. Is going to be used as my spotlight, and I'm going to demonstrate to you how the intensity of the light will affect how you can actually see the subject, which is the two cars that I have here, also being the distance that it is away from each car. So the distance as well as the intensity of the light will determine how much of the vehicle itself will be illuminated. With that being said, I'm going to go ahead and start my demonstration. I'm going to step away from the screen. It may get dark in the room. I'm going to shut off the light and have just my spotlight on, and I will show you change the intensity of the spotlight as well as move the spotlight away from and towards the cars that are here on the platform for you, so you can actually see how that relates to physics and how it relates to the inverse square law, meaning that if you were to cut the intensity of the light down or cut it in half, it would show you that you won't get as much illumination on your subject itself. So I'm going to step away from the screen now. I'll be back momentarily to go ahead and explain what I'm doing for the rest of the video. As you can see, at this time I have the spotlight on. You can't really see the vehicles themselves unless I move the spotlight. At this time I have it maybe 3 feet away. If I move it further away, as you can see, the light itself covers more of the area, but you still have a hard time trying to see where the vehicles are. You can only see one as I'm over here at the tail end of the red Corvette, and then as I move over towards the yellow Camaro, you can actually see that car itself, and you can see just the bare minimum. Now I'm going to keep the light at this distance, and I'm going to adjust the intensity. And as the intensity goes up, you are able to see more of the scene itself. You can see the actual cars themselves. You can see both vehicles. You can see the shadows. And if I move closer, you will see that the light itself becomes brighter because it's closer to the actual scene. Um, with that, you get more reflection off of the vehicles because the light is closer to and it's more intense. Now I'm going to raise the intensity just a little more so you can see how different that will be. Now that's the last step for the intensity. With that, you can see how it's really bright, and if I move the light away in any direction, it still shows you both vehicles themselves. Now I'm going to come back and set the light right behind the cars, and I'm going to move up away from. It's still very intense here, but as you see, you can cover more ground with this light, and that both vehicles and the entire scene is being lit. I'm going to dim the intensity, so I'm going to reduce the intensity of the light, and now as you can see, I'm still at the same distance, but once again you can't see both the vehicles too well. I'm going to come back down, moving closer to, and I will angle the light to where you can see both cars in the scene. And this is how the inverse square law of light works in reference to the light itself, the distance that it is from the objects, which would be the cars that need to be illuminated. And when the light is moving around them, it shows you how intense that it is. Now, also take into consideration the make of both model vehicles. One is plastic, and the other itself is made of metal. Bear with me 1 second, my screen just went black. Okay, as you can see that the red car itself is made out of metal, which has more reflectivity, and the yellow car is made out of plastic, which the reflectivity isn't as intense there, so you'll probably get more of a dull reflectivity from the yellow car. But this is how the inverse square law works in reference to light. I'm going to turn the lights back on. And once again, like I said, I am Denton Williams taking Fundamentals of Physics, and Ms. Rombach, Corin Rombach, is my instructor. Thank you for your time.